Hello everyone, welcome to the Nastel Tech Talk. This is the first in a series of Tech Talks that Nastel will be presenting bi-monthly. The one we have up today is called Detecting Memory Leaks. Our speaker is Albert Mavashev, CTO at Nastel Technologies. Albert, take it.
Hello everybody. Today's topic is JVM resource leak detection using AutoPilot M6. And what I'd like to do is spend a little bit of time talking about leaks as well as normal versus abnormal resource allocation behavior in the applications and how AutoPilot can be used to detect abnormal behavior. So what I'd like to do first is go through a couple of slides and talk about leaks and the resource allocation and some chart patterns, and then talk about exactly and actually show a real demo of how AutoPilot can be used to detect such leaks. So let me switch to a presentation. So if we look at the typical causes of leaks, and in fact this applies to JVM, but really is not limited to JVM. The same paradigm applies to operating systems, C++ applications of .NET. What you typically find is typical causes of such leaks is, from my experience, typically programming errors or bugs. And some of the examples of such leaks are unchecked arrays or hash map growth. Applications are adding stuff to the lists and for some reason not able to clean it up or remove those from the lists. Then you have some errors that are related to the usage of certain resources, such as creating JDBC connections and not closing them properly, even though the objects are being garbage collected. It doesn't necessarily mean that the resources allocated by underlying databases are actually been allocated or deallocated. So typically you'll find application developers are not closing properly either file handles, sockets, or prepared statements. Leaks in the threads, as an example, thread leaks, which applications are spawning threads, and these threads are not properly shutting down and creating leaks. Very tough to spot class loader leaks, and the resources that are allocated outside of the JVM, especially for the applications that are using outside third-party libraries or for example, JNI. But regardless of the reasons for these leaks or abnormal resource allocations, one of the challenges, especially in the application development and also in production support, especially when you deal with composite apps and multiple or many moving parts, is ability to spot resource or components, systems or subsystems that are actually exhibiting what I call resource accumulation or unchecked resource accumulation, which some people refer to as leaks. So let's examine some of the chart patterns. If you look at the chart pattern at the bottom, you see that we're monitoring, for example, the heap utilization of several JVMs, and as you can see, green, blue, and red are indicating their behavior in the heap utilization. So you find that the memory goes up and down, and the question is this does this pattern exhibit a leaky behavior or not? And in fact, it's actually very easy to spot. If you look long enough for these leaks, it's easy to spot these types of problems. In fact, if you look at the chart pattern here, you'll find that the heap utilization is constantly growing until it almost reaches 100%. So obviously, this is kind of an accelerated chart pattern. It all depends on how quickly applications actually accumulating that resource. And obviously, if that happens over a very short period of time, it would cause a JVM to hang and eventually application fail. So the challenge is here is to be able to spot these types of this type of behavior without having to have people actually looking at those chart patterns. Obviously, if you have somebody who's constantly going to be looking at these and trying to figure out what is what, it's possible that you can set up certain charts and put it on the display and have kind of on-screen or eyes-on-screen monitoring and see if there's actually a leaky type behavior. But in most cases, it's not practical. So what we're doing here is actually using AutoPilot to detect memory leaks. And the way that we're approaching this concept is we're looking at, we're basically applying AutoPilot M6 to detect these types of patterns behind the scenes without having to actually people looking at those charts. So an example here, we're looking at the, and we actually showed that an example live. We have we're monitoring we're monitoring a set of application servers here. We're looking at the heap utilization, and then at this point, at this juncture, we've detected that this application is exhibiting a leaky type behavior. And what we've done here is we're actually using the momentum oscillator, which is one of the analytical indicators that AutoPilot uses to determine the speed and momentum of a specific set of KPIs. Now, in this case, we're using actually a heap utilization KPI to determine from 0 to 100 how close you are to 100%, as well as how quickly the KPI actually changes. And the measurement here we use is called the momentum oscillator. So what I'd like to do right now is actually switch to the running product and show you how that's actually used. If we bring up AutoPilot, and in fact, here's the AutoPilot console where we're monitoring 3 VMs in this case. In fact, I have 4 VMs, and the 4th VM is where we're going to simulate a memory leak. So we've got an average of 76% or 78% JVM usage. We have some JVMs here that are fairly high memory utilization. However, their relative oscillators are all around 50 range. What it's telling us is that even though some of these JVMs are actually running at a fairly high memory utilization, they're not exhibiting the leaky type behavior. Now, if we're looking at and we plot the oscillator itself, we find that most of these oscillators are fairly consistently around 40 to 50 mark. And typically the oscillator, the momentum oscillator, oscillates between the 0 and 100. The closer you're to 100, the more likelihood that you have a resource hog going on, or an application that's actually hoarding resources. So why don't we do this? In this case, I'm going to actually start an application that's actually going to exhibit a leak. And as you can see, this is going to be a 4th JVM. It's going to start at about 12%, 12% heap utilization, and we're going to see exactly how AutoPilot is going to be used to actually detect the situation. So this application is actually running. It's going to consume some resources. We're going to see up and down movements in the memory, and the job of this policy, the way it's set up, and I'll show you an example of the wizard and how it's actually doing that, is to be able to detect that the JVM was 4, and the way it's actually consuming memory is actually misbehaving, or it's a resource hog. So in this case, again, this application started. It's still kind of moving in the 17 or 18% range, and the oscillator is still in the normal. Now we've moved up in the upper range of the 20% JVM utilization. Now we're moving in the 22. So again, we're looking at this pattern. We haven't yet, we're building a baseline here automatically to see what the behavior is. So we haven't yet spotted. As you can see, the RSI hasn't been computed yet. So we need a few samples to be able to figure out whether this application or whether this specific VM instance is in fact leaking memory. So let's just wait a few samples. Now we went into the 35% utilization. So in this case, the application could have been still, let's say, accumulating resources, or it's hoarding resources. And we moved from about 17% to 30% utilization. Now, as you can see, these VMs are running at a much higher heap utilization. So we'll see how AutoPilot is able to detect this leak. As you can see right now, we've actually turned warning. And what the AutoPilot is telling us is the momentum indicator is actually showing us is 80%. So in this case, we actually turned critical, showing that even though we're at 43% memory utilization, this behavior is in fact a high likelihood of a memory leak. Now we can see how this actually will progress. So at this point, we'll actually send out a notification. And in fact, I have the notification configured here. So if somebody wanted to know what the and in fact here I'm actually sending an email to myself about this leak. So let's see how this actually progresses. Again, we see that same chart pattern, again, accelerated chart pattern where memory is consistently growing and went into critical. So essentially, we're right now at 65% memory utilization. But at this juncture right here, a notification would have been sent to whoever's responsible for this specific JVM, telling them that the behavior of this JVM is abnormal, meaning it exhibits resource hoarding behavior or leaking behavior. The RSI, as you can see, the strength indicator went all the way over 70, and now in that range, going very close to 100 mark. So in this case, we're already pretty confident that this application is exhibiting a leaking type behavior, went all the way from 18% all the way up to the 85%. Obviously, if this problem is not mitigated at this level, and hopefully there are application support groups and personnel that are trying to address this problem, the application will actually get to 90 or whatever, 100%, and will eventually plateau and will most likely fail, or will cause an application server to hang. And we'll see that effect actually happening in real time. As we're climbing to 94, 93%, essentially as we're getting into that range, the garbage collection on the JVM is going to start kicking in more and more often, and obviously cause a tremendous performance degradation in the application performance. So in this case, if we're monitoring a farm of an application service, could be 2, could be 5, could be 10, could be 100, we can holistically spot these types of behavior and pinpoint to the VM instances, in this case, Webster application server instances, that might be exhibiting this type of behavior. As you can see, we've plateaued right here. We're hitting about 99%. In this case, application can no longer allocate resources, and we start fluctuating in that range. And in most cases, obviously, the application server at this point will most likely fail. So again, this is an example of how we use a momentum oscillator to be able to detect abnormal behavior. Now, what I'd like to do now is actually stop it and show you how AutoPilot is actually using these momentum indicators. So what I'd like to do is stop this, right-click on the leak detection, going through the wizard, and what we're doing here is we are collecting WAS information, or web for application server information for 3 application servers, and we're monitoring information such as handle counts, heap utilization, GC duration, as well as the thread count. Now, we can do these patterns and pattern detection across all. Now, in this specific example, we're pattern matching heap utilization across all application servers, right? So regardless of whether you have one application server or a farm of 100 application servers, this one template will actually be able to detect if you have a leak in one of the application servers. So as we go forward, we're looking at any application server that has a memory utilization of at least 0. So we're looking at an application server that has at least some memory allocated. And here, as you can see, typically, people that use AutoPilot typically use what we call a value and compare it to a certain threshold. But in this case, what we're doing is we're actually computing a historical RSI, which is our momentum indicator. So it's a historical momentum indicator, and we're comparing it because it oscillates between 0 and 100. We're comparing to 80 and 70 mark. Now, typically, if you're below 70 or below 60, that is considered to be a normal range in terms of the momentum, which means there's not much momentum in the KPI itself. As we start climbing, that typically indicates that the gain is outpacing the losses in the actual KPI. In this case, the gain in the underlying memory utilization is dramatically outpacing the deallocations that are going on in the JVM. And as we're climbing below 80, about 80, we're going into the critical versus warning. We're staying below 80 at about 70. As part of the next step, what we want to do is actually send ourselves a notification. In this case, I send myself an email every time one of the JVMs actually hits either warning or critical situation. And again, this could be either an email or it could be user action or it could be nothing. But in this case, I want to be notified when the JVM goes into this kind of spin mode and then finish. Now, this sensor is in fact almost identical to the previous one. The only difference is that we're actually plotting the value that we're displaying is the RSI itself instead of the heap utilization. So again, I'm going to turn this back on, and we're going to see that our RSI is kind of dropping a little bit because, again, there's no more allocations in the JVM. So the JVM, this specific JVM memory allocation has plateaued. Let me switch a little bit to kind of talk about some of these indicators. Again, this applies to, even though we kind of took an example of a heap utilization, this equally applies to if you want to track or look at the handle leaks, heap utilization, or GC. So we can apply the same concept of the momentum to be able to actually detect normal or versus abnormal behavior in how resources are used
now for questions and answers.
in the underlying operating system or VMs such as Java or .NET.
To the question box.
And with that, I'd like to conclude the session and open for Q&A.
All right. The first question we have, Albert, can the methods that you showed in this be used to detect non-Java resource leaks?
Yes. As I pointed out during my session, the methods and the oscillators that we use are actually API agnostic. It could be used to look at the resource growth regardless of the actual technology. So whether it's thread leaks or memory allocations or anything else, regardless of the underlying technology. As long as we are tracking the KPIs and collecting the baseline and historical information, able to understand gain versus loss as it's related to the overall historical record of the KPI, we can pretty much, with a high degree of probability, predict whether the behavior that we're looking at is in fact a lead to type behavior.
Great, Albert. We have another question here. How much history is required to determine a leak?
Typically, for us to determine for the oscillator to be somewhat accurate, you need about 50 to 100 samples at least of the underlying KPI. Obviously, we can, the more history you have, the more accurate you become. And in fact, in that sample that we had before, if the memory would have come up to 90, let's say 99, and then dropped down back to normal range and then started climbing again, the oscillator would in fact pick that up and would not actually show up as a warning next time around. So typically 50 to 100 samples and then rolling the baseline as we collect more of those samples.
Thank you, Albert. Looks like we got a few more questions here. The next one, can other indicators be used in conjunction with memory to determine things like resource leakage?
Yeah, absolutely. And something that I haven't shown, but maybe potentially for the next talk, is where we can actually combine and build an oscillator that's actually built on top of memory utilization, GC frequency, and the length of the GC as an example, and combining with I/O rates and CPU rates, where we can actually look at as the resource building up and the resource contention is building up, that it gives us a more accurate picture of the resource contention and leak type behavior. So obviously, other indicators combined with the utilization can actually provide a more accurate picture of what's actually going on with an underlying application or application set.
All right. The next question we have is, can you identify the root cause of the leak? And if so, how would you do that? Albert?
Yes. Today, what we're doing is we're identifying a high probability instance of the VM that's actually leaking memory, whether it's VM or .NET or whatever. And then what we typically can do is trigger a heap dump. Obviously, in order to identify the root cause, somebody's going to have to actually look at the underlying heap and understand where the objects are actually allocated and who's responsible for the allocations, whether it's a thread or a specific process or a specific application. So in that case, what we're doing is, as we detect a high degree probability of a leak, we can then trigger a heap dump, and then obviously one of the Java or developers can have to actually look at the heap dump and identify what's going on. Now, there are plenty of tools out there that actually look at heap dumps today. So once we identify, take a heap dump and then have the analysis done based on some of these tools and determine the root cause of the leak.
Thank you, Albert. Looks like we have another question here, too. Can you detect deadlocks or other resource contention problems? Albert, you want to take that one?
Yes, we can use existing methodology and tools available in AutoPilot to detect deadlocks. Specifically around Java, we do have a way to tap into the JVM and do some thread analysis and determine whether certain threads are deadlocked. Obviously, it's much more difficult once deadlock goes outside of the JVM. And we can use some statistical analysis there to figure out whether the activity that we're looking at is in fact similar to the deadlock. So overall, we should be able to detect deadlocks in the JVM, and if it goes outside of the JVM, we can look at the pattern of activity and decide whether it's an activity that is very similar to what the activity looks like when the application's deadlocked.
Another question arose, Albert. What platforms do you support? Windows, Unix, Linux, ZOS, iSeries. Help me understand that. Albert, what say you?
Well,
we're actually platform agnostic. So from the leak detection standpoint, we can collect KPIs such as memory, handle, CPU, garbage collection, pretty much from any Java platform, whether it's distributed or Z or some other platform. So the platform is platform agnostic. Now we can obviously collect KPIs from any JVM, as well as other non-JVM platforms. So it could be operating systems, .NET, or other platforms that have resources that are consumed by the applications.
Another question here. Do you use an agent, and is it loaded with JVM Start?
an example here, it's an agent, but again, because we're monitoring utilization and key cycles, we don't necessarily have to be within the JVM itself, even though we do have an agent that actually starts with the JVM. We also have remote agents that can connect to the JVM remotely, if you're familiar with GMX, and be able to pull some of that information in. Now, we do have a way to actually do some heap analysis. Now, in that case, you do have to actually start it, or actually embed an agent within the JVM as it starts. And typically, Java agents and provide a command line and start with the JVM as it starts.
Can AutoPilot remediate the detected problem?
Yes, AutoPilot can help users remediate problems, although in the case of leak detection, there are very few real remedies, other than most likely taking a heap dump or trying to analyze the heap and understand, what's causing a memory leak. So in this case, we could take a heap dump and also help you analyze the heap as well to try to figure out where the problem is, or maybe spin off another JVM instance or restart an application or an application server. But those are the several remedies that you have when dealing with a memory leak. In other cases, obviously, we have things like to be able to start a script or launch an executable, which allows users to really provide any remedy they would like based on the certain situations that we detect.
I want to thank everyone for attending today. I hope you found this helpful. This will be posted on the Nastel website, www.nastel.com, by the end of today. Also note, this is the first in a series of Tech Talks by Nastel, and you'll find one later in June. The topic on that will be what's new in WebSphere MQ 7.1. Thanks again very much. Bye now.